Please join me in welcoming for our lightning talks, Adam Pennington.
Thank you, Katie, and hopefully they'll get the slides up soon. So lots of people have talked about in the past that they really liked some of the short talks that this conference has done. That, we don't have any 50-minute talks. We're just doing short all the way through. So this is going to be even shorter. Just a couple weeks ago, we put out an additional call for presentations, asking people to give us their 5-minute pithy war stories, their half-baked ideas. And I think people really delivered on that. It was selective, so we had more than just the people up here today. We're going to be running these back-to-back. There's no time for Q&A. We're going to be going strictly timed at 5 minutes. I'm going to be showing you the timings that the speakers are also seeing so that you know how close they're actually going to get.
Hello, everybody. I'm Brian Donahue. I work at Red Canary. I've worked on last year's threat detection report. I helped produce and write that. I'm currently helping produce and write this year's threat detection report. And in the spirit of sort of getting to the point quickly, in case I get cut off, I think that everyone should be taking the threats that they observe on their network, whether it's their own enterprise's network, or maybe it's the network that, or sort of the networks of your customers that you are monitoring in the course of business. I think we should take all of those threats, map them to MITRE ATT&CK, and then release what we find in the form of sort of prevalence rankings. And the reason I want to do this is because I think we should be creating a sort of like grand unified MITRE ATT&CK heat map. And the reason I think we should do that is because I don't know that we make really great scientific decisions about how we resource allocate in security. So the other day I was reading an article in Cyberscoop, and it was about how the security insurance companies are going to be in position to dictate the tools that we buy. So they create a whitelist. If you buy a tool on the whitelist, you get a discount on your premium. And my initial thought was, wow, that's a horrible idea. And then I thought about it a bit, and it's like, who's more incentivized to make sure you don't get breached than the company that's going to have to pay for it when you do? So that got me thinking, like, how do we make these decisions as is? And I've got like a list. It's incomplete. I'll just say ahead of time, the list, each item on the list has pros and cons. They're all flawed, and none of them are scientific. So sometimes we've got experienced people on our teams. We let them use their intuition to decide how they're going to resource allocate. Sometimes we go and we talk to an analyst firm. Other teams read the news, read about an attack, try and build out coverage for it. Circumstance plays a large role in this. So maybe something bad happens and you have to buy a tool. There's plenty of firms out there that probably just do this based on sort of regulatory and compliance requirements. And then I bet a lot of us just kind of make arbitrary decisions. So the question is there a better way? And of course the answer is yes. All you have to do is figure out the threats that are most likely to occur and sort of focus on them first and then move backwards to the ones that are less likely to occur. Luckily, MITRE ATT&CK gives us kind of a nice framework to work with for this. It sort of like takes this nebulous, indefinite thing, a threat landscape, and makes it definite and sort of gives you a finite list of techniques and the data sources you need to sort of observe those techniques. So I think of this sort of like in the terms of baseball. So like forever you just sort of stuck 9 players on a baseball field, evenly spaced, and that was how you played defense. With the advent of advanced analytics, increasingly we're seeing infield shifts. So we've got spray charts for batters. We sort of know where they're going to hit the ball, and you move the infield accordingly to neutralize their strengths. So I'm sort of thinking of that in terms of MITRE ATT&CK, where the framework itself is the baseball field. You don't want to just throw coverage at the entire matrix. You want to figure out the hot spots. So a year ago, we started producing our threat detection report. And the idea was, let's figure out the MITRE techniques that we see most often so that we can answer a few questions. One being, how do I get started with attack? Another being, how do I use attack? And maybe a third being, like, how do I prioritize coverage? So I'm thinking that, like, if everyone does that, we won't have Red Canary's very endpoint-centric view of how you should prioritize coverage and which threats are most likely to occur. Like, we should have everybody's view on that. I want to know what firewall companies are seeing. I want to know what sort of email filter makers are seeing. so that we can get like a really universal view of how the threat landscape plays out on the attack matrix. So I found 3 problems with this as I was preparing for this. There's probably more. I'm not that creative. But interestingly, 2 of those problems were solved yesterday. So I'll start with the ones that have been solved. The first one I couldn't figure out was like, how do we normalize the data? Because a company with 1 customer, their prevalence rankings are not going to be the same as a company with 10,000 customers. And then the other problem I saw was how do we aggregate it all? And I actually think that MITRE is solving both of those problems potentially with attack sightings. So I'm interested to see where that goes. Now, the third problem I'm seeing is it has to do with sort of the nomenclature. Like attack gives us a nice common language, but we don't have a common language to talk about things like detection and alerts. Like we call them detections at Red Canary, and that's sort of what we are ranking and applying to MITRE ATT&CK when we create our threat detection report. But that's not necessarily what other people are doing. So go forth and create the grand unified heat map.
I'm here to talk about dashboards, and I can think of nothing scarier, spookier, than a useless dashboard. But who am I? My name is Dan Cole. I'm the director of product at ThreatConnect. We're an Intel-driven security platform. I've been there about 4 years. I love Star Wars. I love my dog. I love threat intel. And I love explaining dashboards to people, so this is a perfect talk for me. Now, to figure out how to use attack with dashboards, we need to talk about what dashboards are not. And I want to talk about the pretty picture fallacy. Oftentimes I hear people dismiss dashboards as they're just pretty pictures. Or you walk a show floor and it's a bunch of blinky lights, a bunch of animations, but that don't really do anything. And it ends up becoming a form of informational bias, where we're just collecting pretty pictures without thinking about the action that we take. And to correct this, we need to think about what a dashboard is actually supposed to be for. So we have a nice long definition from Stephen Few, one of the great modern thought leaders of dashboard design. But to coalesce it, dashboard is about what you need to see to focus on achieving your objectives. So in essence, it's about behavior changing. So if you think about your car's dashboard, it's all about answering questions like, should I speed up or slow down? It doesn't provide extraneous information. So depending on what hat you wear in InfoSec, a dashboard might help you answer questions like, should I hunt, patch, block, change my intelligence requirements, have my intel requirements changed? And the great thing about attack is that it helps you focus your behavior. We've heard a lot of great talks today and yesterday about how attack can help you prioritize things, whether you're prioritizing hunting or doing some kind of gap analysis or prioritizing some kind of response. So if we marry these 2 things, dashboards and attack, where dashboards are all about helping you focus around objectives and attacks all about helping you prioritize, what we end up with is a very boring looking dashboard. It's just a bunch of tables. It does not have blinky lights. It does not have fancy pie charts. It does not have bar graphs. But, and this was created, inspired by an actual user, this is sort of their daily driver of what they take a look at every day. So they've got tables, boring looking tables up here that show indicators related to a specific technique that they happen to be tracking as part of their intel requirements. They can see indicators related to incidents that leverage a specific tactic or technique. They can manage or look at incidents related to a high impact tactic. In this case, I think they've got exfiltration and C2. But it's all about putting the things that they care about, that drive their day, in front of them so that they can focus only and specifically on those objectives. And the way this works is, behind the scenes, we have something called ThreatConnect query language, which is sort of this SQL-inspired way of asking complex questions of your threat intelligence. So all we're doing to bubble these things up to that tabular dashboard is saying, okay, show me all incidents and campaigns matching a particular technique, or show me all data related to a particular tactic. And you can ask about around ID, you can ask around the name of the technique, you can ask around the tactic, you can ask very complex questions like, show me all incidents coming through that are tied to adversaries, that are tied to previous incidents that have been known to use a particular technique where that technique affects the Windows platform. That level of granularity is possible. So to sum up, dashboards, not about pew-pew maps and pretty pictures. They are about focusing your behavior on specific objectives, hopefully driven by Intel requirements. You want to orient those objectives around attack. And by creating this sort of customized dashboard, it lets that dashboard turn in to your sort of daily driver to help you focus. Thank you very much. One last picture of my dog, and I'll yield the rest of my time.
Hey everybody, I'm Stefan Chenette. I'm the CTO and the co-founder of ATT&CKcon. I got to know the attack team somewhere around 2016. So since then, I've been working with attack one way or another. Some of the contributions from my team have gone into the Verizon DBIR report example with regards to attack paths and attack mapping. But what I'm here to talk about is, in that time, my observations with working with security teams in operationalizing attack. More specifically, as I was looking at the lightning talks and thinking about a subject, was how I've observed some of the security capabilities and the maturing security capabilities that organizations have, and what use cases actually make sense to get started. So you don't just wake up in the morning and have a threat intel team. You don't wake up in the morning and have a red team. So where do you actually just start with attack? So I'm going to share some of my observations. The hope here is that this is going to help you actually focus and get started faster. This is a lightning talk, got 5 minutes, so I'm not going to go to the level of detail, talking about levels 1 through 5, security capabilities being undefined to optimize. We're going to keep it simple. So when I talk about security capabilities, what I'm referring to is an organization's ability to prevent, detect, monitor, respond to an attack with their people, process, tools, and technologies. And really, as your program matures, it earns the right to then have more capabilities. So over the last number of years, in working with several security teams, there's been an interesting mapping that I've observed as teams have increased in their capabilities, and what use case they've completely failed in operationalizing, but more importantly, where they've succeeded in operationalizing the use of attack. So where do we get started? So the first set of groupings, this could be relevant to a new security program. This could be relevant to the fact that you have your security program in place, but you have these fundamentals. With the people in place, security analysts and security engineers. Okay, you've put in place basic endpoint detection capabilities, basic network detection capabilities. Your security engineers are maintaining and putting in more security controls and those technologies and processes. Here's where I've seen success. At this point, it's not putting attack into action. It's putting it in the way of the team to reference simply as a reference library. The amount of success I've seen in teams just to start off with this simple concept, use it as a reference library, start talking a common language. This is a theme that I've seen this week that we haven't mentioned, which is the change in culture. So as a team starts talking the same language, it changes the mindset. So super simple, really changing culture, use MITRE ATT&CK as a reference library. As security analysts, security engineers start to grow, the team, the program starts to mature, the assessment engineering use case comes into mind. So where I've seen success in working with security organizations is going through these iterative exercises of looking at attack as a matrix and overlaying the controls that have been put in place, the detection, prevention, response capabilities for your team. And it's an iterative exercise. And so it's constantly, as the analysts and the engineers are more familiar with their environment, let's overlay that onto the matrix and understand what attacks are we defending and preventing against. Detection analytics, again, more complex set of engineers who are using this from a POC perspective, an analytics perspective. but it now shifts this cultural change to represent red teams sharing the TTPs, blue teams learning and sharing back to the red teams. With threat intelligence, now a new capability, if you will, this comes into kind of 3 different areas: threat hunting, incident response, and gap analysis. So if you have these capabilities, excellent, this use case is for you. And where I've seen success in teams is using it as a common mapping. So these tactics and techniques, as you're building internal processes for capturing threat intel, capturing external threat intel, mapping this all together, this use case makes sense for your capabilities. Now, close to my heart, adversarial emulation. This is extremely important. This is really when you start thinking about the purple team mentality. This is also the point where you think about attack paths and you think about impact to your organization. And you're mapping that to your security capabilities and understanding where you need to improve, where you're failing, and you're discussing that with the rest of the management team, the rest of the company. So again, as you're kind of reflecting on some of these thoughts, it's less about your industry, and it's more about what drives your security program. It's more about where your capabilities are. It's more about what use cases to choose. Thank you.
Ivan Ninachuk. You both hands.
I've been validated by my peers. Okay, so we got attack poker, which is a lot of fun. So first of all, though, none of us work in a vacuum. So I'd like to acknowledge my colleague, Jeff Whitaker, who better be watching right now. Without his constant contributions, I probably wouldn't be here. Let's see. So I'm going to cover the main themes of the conference, which is actually kind of cool. The first one is attack as a game. We heard some great motivational speaking yesterday. I know I had a wonderful session with Shane Steiger. He brought his little TCG Magic Gathering type game called Maelstrom, and we talked and nerded out on game theory. But why does it work so well with attack? Well, basically because it's so abstract with the techniques and tactics. And then also, as you can see, you can prioritize, you can make decisions, you can do payoffs of resources. So why is it poker? You might say, how in the world is it poker? So the concept of attack poker is that the cards would actually have their techniques and tactics on them. And so you could start matching those chains of attacks that's also been talked about. So that's another thing. So you can start looking at what combinations, because in poker, say you have a pair, right? Okay, maybe some resources, put some chips in. The chips are resources. Put some chips in. You might win, you might lose. Who knows? Now, if you got a full house, you got a... Now, how does all this wonderful abstract poker playing on Unreal 4, because I'm making the mobile game, but how does it help to be? The other cool thing about the theme that I loved hearing it over and over again, communication. But I take it one step further. Claude don't get you anywhere. Maybe they're going to be too resource heavy to follow up on. So that's the noise there. And then the cool thing about this is that for me, the message is the true positive, okay? And then the symbols of the message become your alerts, or because we smartly map to MITRE ATT&CK, they become your techniques. So you're actually making up the true positive using those combinations. So if we can find these statistics that we can get from things like attack poker, like Maelstrom, like sightings, like, what was the other one I was gonna use? Oh, emulation. If we can get those statistics and start making these models, then, like I said, we can start actually using good old theorems from 1948 that successfully developed digital communications. Oh, there's the timer. Okay, keep looking over there. I'm doing great. Time-wise. So, like I was saying, then we can actually start optimizing our alerts. Or, I'm going to use another word everyone's been using, prioritize attack poker, was to find a way to be able to game to information to prioritization. It's wonderful. So, on other notes, I like Excel sheets. But I'm moving to Jupyter notebooks. Come on, drink it up, drink it up. I hate candy corn. I'm sorry. I know I just got like never coming back here again, apparently, but I just can't do it. My dad loved it, though. We always argued. Thank you very much for this opportunity. This was my first time speaking ever, and I was so happy to do it. Thank you.
I'm Mauricio, everyone. So we have 5 minutes, so my intro is going to be real quick. I run a blue team in financial services in New York, and I love threat hunting and adversary simulation. And if you want to know more about the things I'm working on, check out my Twitter and my GitHub. So Attack is a great tool that we can use to measure our security posture against techniques used by real attackers in the wild in real attacks, right? But in order to achieve this goal, we really need different technologies, right, that serve different purposes. And I think one thing that we're not talking too much about, or at least I haven't heard, is the tools that we're using, the technologies that we're using to kind of help blue teams keep track of this security posture state over time. And most importantly, collaborate as a team and share notes, share documentation as we're working on tracking these techniques. So that's what I want to talk about today. I want to show you one way of doing it, how we do it, and also I'm going to release a tool that can maybe help you do it yourself. So as we started our journey with the Attack MITRE framework, we started, just like many of you, we started using spreadsheets. And Katie, nothing against spreadsheets, I promise. I actually support the spreadsheet movement, but we wanted to use something different, and we laid out our requirements. So our requirements were, we wanted a way to manage attack techniques as entities with properties. Some of these properties are static, some of these properties are dynamic, so we can track this state over time. We wanted an interface that would allow our team to collaborate, to log work, to share comment, to share analytics in one simple interface. And we wanted to get some basic reporting. So I'm going to stop here and move to the demo. So before that. So this is our tool we wrote. So Attack to Jira. It's a simple Python script that leverages Jira's API, leverages Roberto's Attack CTI library. And it's basically going to automate the process of setting up a Jira environment that has all the attack techniques and allows you to assign it to people, collaborate, work. So I'm going to just jump to the demo. Hopefully this works. I guess it's not going to work. Let's see. Oh, unfortunately, is this working? So, yeah, all right, it's not going to work, but that's okay. So what this was going to show, and you can check on the GitHub, it's going to have the links to the videos. What this was going to show is a really easy way where you can run the tool. It's going to do a few things. It's going to create a Jira project. It's going to create custom fields, because Jira comes with out-of-the-box fields that we don't need for software engineering. So it's going to create custom fields, hide those unnecessary fields, and basically create, talk to Attack's API to get a list of all the techniques, and basically create a Jira project with all the attack techniques that you have. And it takes around 5 to 6 minutes. So in 5 minutes, you can have a full environment in Jira that you can go ahead and just start assigning to people, running reports, changing the maturity state. You may start in a node track. I have a maturity matrix that you can customize, just changing a JSON file. And then also Jira allows you to run basic reporting, right? So you can run reports, and they even have a JQL language, so it's really easy to run reports. But one thing that we did also is that we wanted to leverage the attack navigator. So we have basically an extra feature on the tool that uses that maturity level that you can work on your team and track over time. And it's going to export a JSON layer based on that maturity level on the Jira custom field. And then it's going to be easy, really easy to create and have a visual of your attack coverage as you work on it, right? So I encourage you that now the code is out there, so you can go to this GitHub, and in this GitHub page, you're gonna find the video. So it would have been really nice if the videos work, but that's okay. You can watch the videos there, and I'm really looking forward to get comments from if this works, if this is an approach you like. Let me know. I'm gonna keep working on this because we use it. And finally, also we also have I created this Jira instance. It's attack.atlassian.net. And I've created this Jira instance with the tool, and now I made it public, anonymous, so you can access it. So if you want to play with it, with this approach, maybe it works for you, just go to this URL, attack.atlassian.net. Once again, it's going to be on the Jira GitHub repository. And maybe it's another way that we can track and measure our attack coverage over time. So thank you.
Ivan earlier today mentioned carrot, and now we're going to bring the sticks. Hashtag dad jokes. You can follow those on Twitter if you ever want to get through your day. There is an entire group of us who are just as demented with these puns. Tony, aw, who said aw? It'll come back, don't worry, I'll need to illustrate it, but it gets hot in this thing. Tony was the keynote. She said something really interesting. She talked about commitment. And we all understand that projects and change require commitment. That's what executives have to do. It's what engineers have to do to actually make something happen. And the theme that I've pulled out of the last 2 days is seeing that commitment in action. Deloitte, Nationwide, CrowdStrike were all example of commitment trying to make a system work through individual heroics. MITRE showed us the TRAM project, which was using natural language processing to let's find a way to look through analyst reports and try to automate some sort of understanding of what they're doing. So there's all of this information out there. We're all telling each other to share, but why don't we make it easier as a community? So the commitment should not be to us as individuals, but community commitment to making this a better standard that all of us can use. So I'm actually here with somebody else in costume. I'm obviously the unicorn, and Dan Rydell is Harvey the rabbit. Dan is in Paris right now, so he can't make it, but I did some things, and Dan is on the board of directors at Oasis. So today's threat intelligence. I'm going to start by, I picked a random vendor, and I'm not going to say who they are, and I'm just going to read some of what they do. They have the most advanced automatic, deep, and dark web CTI platform. They are a cool vendor of Gartner. Then they had something else that was really cool. Where is it? Right here. Invisible to cyber criminals. It extracts intel from them. So what's the problem with threat intelligence? The problem with threat intelligence is we're always understanding yesterday. It's reactive. And so the key is, how do we make it as quickly as possible from reaction to application? Today's threat intelligence is based on static IOCs and identifiers. Here's a hash, here's a signature, here's a domain, here's an IP. This is what I just learned. But the bad guys already know that. It's not hard for them to build changes into the malware. It's not hard for them to shift infrastructure. And so we're left trying to play catch up. And so if we can shorten that loop, this is why having a machine-readable approach to threat intelligence, where instead of trying to read the reports and then do something, well, what if we had a quicker way to make that operational? So STIX 2.1 is coming. STIX 2.1 does implement some of these things that, combined with current STIX patterning, is going to make things more machine-readable, but it's still missing some pieces. First of all, we have an accuracy and quality problem. Analysts should not be debating what something is because there are mistakes made. We also have problems of duplication. Who here is overwhelmed with data? If you're not raising your hand, I will come say hi to you in the audience. All of us. At the SOC, it's false positives. For the rest of us, we're buried in, this is kind of what Keith was going with his red canary. Where are you, Keith? Right there. Was talking about was this balance of trying to collect everything, but at the same time making it usable. It's called the National Security Agency problem. That was a joke. Think about what the problem was. Hey, we collected everything. What do we got? Nothing's actionable. There's too much. Now tie this back into attack. We see, I think attack has been abused by industry for similar reasons. We've turned it into a checklist. We've turned it into trying to chase it. We turned it into engineering directly detections for it. And instead, I always think of attack as a periodic table. We're trying to describe a chemical equation because one piece of attack tied to another piece of attack tied to another piece of attack equals something else, and there's a state basis to it, the proverbial unicorn. So we want our threat intelligence to be able to capture that same factor of, it's not just a checklist of things. I haven't just tagged these things, but I understand the context, the order, and the state of what's happening. So, of course, starting with Katie and always ending with Katie, this could become a machine-readable format that we could actually use and operationalize threat intelligence if we all commit to it together as an industry. Thank you.
Our next speaker up is Emma McMullen. reset just a sec. Give you both.
Great, thanks. Man, I feel so underdressed now, guys. Where's my onesie? All right, so I'm here today to talk about attack, intelligence, and purple teaming. And before I get started, I have to give the obligatory caveat that my views that I express today are my own and do not necessarily represent those of the Federal Reserve Bank of New York or the Federal Reserve System. All right, that's as fun as it's going to get today. All right, so purple teaming. What do I mean by that? Sounds very buzzwordy, so please forgive me. But really, you know, everyone here has been giving such great talks the past couple days, right? People are doing detection. People are doing really cool heat maps that aren't just pew-pew maps. And people are also doing purple teaming. We heard a great talk about that earlier today. But why do we want to do micro purple teaming, and specifically a micro purple teaming workflow? Well, it began, as you might expect, with yet another fusion initiative. I think we've all heard that coming down the line from our leaders at some point or another. So really, we were being tasked with saying, all right, we need to collaborate together, not just, you know, within the intelligence team, but we also want to collaborate better across this entire organization, right? We want you to be talking not just to detection creation, but we want to be talking about hunt teams, red teams. What are all of these other teams within our SOC that we're not talking about? And attack was really the great vector to be kind of that, the common language, if you will, to be that cornerstone, right? Well, we'd already gotten pretty good at this center vertical. So that's attack-based intelligence. On the intel team, we were breaking down our reports into TTPs. We were then handing that off for detection creation. We were integrating that into our reports. And, you know, we were looking around and saying, wow, we've got so many great TTPs. We are so great at this. Who's using them? You know, we're creating use cases for it, but I think there's probably a lot more other ways that we could be using this. And then, you know, fusion call came from on high. So we turned and said, you know, blue team, I heard you're doing a hunt engagement. We've got all these great TTPs. We wrote a giant report. Here you go. Red team, you know, we've heard you're doing a really cool initiative on that side. You know, here's a bunch of TTPs. Here's a great report. Here you go. But we were starting to hit some roadblocks with that, right? Which is that you haven't truly lived until you've written an 80-page report with over 100 TTPs in it. And someone has to read that because it's, guess what, got a spreadsheet attached to it. So that's no fun for anybody, right? And you can imagine that people are super ecstatic when they get that much to read and to work with. So there's clearly some constraints. And even on the intel side, we were finding that was the intel being generated, were these TTPs being generated, you know, truly high priority? Were they really what red team should be knowing about? Or are the TTPs were being created a little repetitive because they're driven by the similar custom requirements to a report we already did on blue team? And if we're doing overlapping work here, does blue team and red team even know they're getting similar intelligence? And what are they doing with it? So we clearly needed to do something. So our solution, make it micro. Instead of doing these big reports, these big workups, these big engagements that take a lot of time and have a lot of reporting, we thought, let's go small. So it all started with a single TTP, which we've got kind of abbreviated here on the left. Cozy Bear, WMI, so tactic, technique. We kind of abbreviated the procedure part, so don't get mad at me, Katie. It was there, I promise. And we gave that command to both red team and blue team at the same time. So red team says, all right, I've got this command that I created to emulate this behavior. And the blue team says, I created this use case that will detect this behavior. And then we deployed it simultaneously in multiple different environments of the FRS or Federal Reserve System. So if any of you guys know anything about that, we're pretty distributed, so lots of different environments there. And we found that, yes, we could detect it, but we also found that in one particular environment, we didn't. So that kind of leads us to these final results, right? Which is that rapid emulation and validation is going to help us be a lot more responsive to high priority threat actor activity. And in particular, give us a lot better assumption, more accurate assumptions on coverage. So that kind of created this new workflow, which is that instead of having a big engagement, we say, all right, Intel has determined this is an event trigger, that if we see perhaps a threat actor exhibiting new behavior, but maybe just one single new behavior, we want to make sure we're covered. We break that down in Intel into different TTPs. Red team is able to emulate it. Blue team creates detection. Then suddenly we can answer to leadership, here's what your coverage is. That question they always love to hear the answer to. And then finally, lessons learned. On the Intel side, we can continue to tune those event triggers, but also we're learning more about our enterprise as we do it. So at the end of the day, purple teaming is great, but let's make it micro. Thank you.
I'm Nick Carr, and this is Guardrails of the Galaxy. So I work on a team that's at the intersection of, I guess, hunting and detection that looks across all of our Mandiant services and then across all the FireEye product tech stack. We spend our time reverse engineering attacker techniques. So why talk about execution guardrails? First of all, this was our first technique, our first new technique added in April 2019 to the attack matrix. My boss talks about them. Here, Kevin Mandia is saying the US uses, their malware uses guardrails, other nations do not. Maybe examples like that were raised earlier by the ESET team. And most importantly, I guess, MITRE attack celebrity Katie Nichols likes my quote from State of the Hack, saying that the hallmark of sophistication is restraint. So if we agree that that sophistication means people are restraining their activities and guardrails are a manifestation of restraint, then it stands to reason that looking at execution guardrails is interesting and has sophisticated attackers. So a quick look here at the combination of the definition with some detection concepts. Just boiling it down really quickly, you're doing a couple things. The attackers are checking an environmental condition, and then they're comparing that to an attacker-supplied value. These are the behaviors in this particular order that you want to look for. I know I'm greatly generalizing it for this quick talk. And then MITRE also includes environmental keying, protecting your payload with that same environmental information. So the use of those crypto functions in that order, again, can tie together. So a couple of detection issues that we run into when looking for something like this. The first is that it catches a lot of recon. If you imagine a non-targeted fish that comes in and collects information from the hosts about the environment and beacons and sends that back to an attacker and encrypts those results. So you run into this, that's still evil, it's just the wrong kind of evil. It's not the guardrails we're looking for. We also see a lot of people confuse what we're kind of trying to talk about here with like more broad AV evasions or VM evasions. Just looking to see if I'm running within a virtual machine isn't what we're talking about because it's not attacker supplied and victim specific. And when you start to look at all of those, you get a lot of other less interesting things in the mix. The other thing that I see a lot of and occasionally share is the insider threat, I guess, to guardrail detection, which is legitimate uses of protecting execution. In this case, here's a bank's macros that are actually checking the computer name, making sure it matches a particular naming convention, checks what domain it's joined to, checks the egress IP address. It even runs interactive recon, and it does all that before it runs a legitimate macro. So that's not malicious. Okay, what you're all here for is the Guardies. So this is the first 3 Guardie Awards for achievement in technical achievement in guard railing. So the first up is the offensive tool Demiguys from NCC Group. These guys do some fantastic guard railing in the wild if you have a chance to look at some of the things they do. But they publicly released this Demiguys tool to encrypt HTA payloads. Rich Warren specifically does a lot here. This example is really neat. It looks for a network attached device. It looks for someone's, where you'd expect to see their router's landing page, looks at the logo dimensions and sees if it matches the logo dimensions of Virgin Mobile broadband customer router. So it's an example of the kinds of things, they do a lot more of these. It's the kinds of ways that you can restrict the more than just like an attacker, a joined domain. Okay, the next one, I love this one. The best use of guardrails in a close access operation. Ooh, this is spicy. Okay, current detection at 2 vendors. I could rant about how that doesn't really represent true detection. But anyways, this is currently out there on VirusTotal. I'll share the link afterwards. You don't have to do the government thing, how you hand copy hashes from screenshots. I'll share it out. But this malware actually looks to see for a specific USB wireless adapter, and then it actually adds in a rogue access point as a WLAN profile. Like it looks for, it creates a rogue access point entry and tries to connect to that for C2. So this is, we believe the attacker was then physically close by with an access point that this malware was designed to connect to and use that as covert C2. So pretty interesting. and interesting to have to override these. Quickly, I'm running out of time. I should have practiced. The Lifetime Achievement Award in guardrailing goes to APT 41. If you have a chance to check out our APT 41 report, you might be familiar with their supply chain compromises where they restrict execution with MAC addresses. You might not know about the Microsoft Crypto API that's tied to an individual user account on an individual system, and you might not know about volume serial IDs to key payloads.
Thank you very much, Nick.